Hey everyone, ready to dive into a wild chemical showdown? Today, we're unlocking the secrets behind something called a displacement reaction. We're going to see how some elements can literally just steal the show from others. And believe me, this matters everywhere, from making stuff in factories to stopping giant ships from rusting in the ocean. Let's get right into it.
Okay, let's kick things off with a classic science experiment. Picture this. You take a regular old iron nail and you dip it into this really bright blue liquid. That's a copper sulfate solution. So, what do you think is going to happen? Is anything going to change, or will it all just stay the same?
So, if you guess that the nail gets a kind of brownish coating and that cool blue solution starts to fade, you are absolutely right. And no, it's not a magic trick. It is a perfect example of the chemical showdown we're about to break down. What you're seeing is the more aggressive iron atoms literally swapping places with the copper atoms in that solution. So cool, right?
To really get what's going on here, we need the rule book. We're going to look at this whole process like a chemical heist, where one element just swoops in and takes another one's spot. It's all about power and position. So what in the world is a displacement reaction? Well, it's when a more reactive element, think of it as a more powerful one, comes along and literally kicks out a less reactive element from its team, from its compound. It's a straight-up swap, but here's the catch. It only happens if the new element coming in is chemically stronger, or as we say, more reactive.
This really breaks down the roles perfectly. You've got the winner, that's our more reactive element, and it completely takes over the spot in the compound. And the one that gets displaced, well, it's now left all on its own, just hanging out as a free element. It's a total chemical competition. But how do we know who's going to win?
For that, we need the ultimate power ranking of metals, the reactivity series. You can think of this as the official VIP list for the entire chemical world. Where an element stands on this list, that determines everything. So check out this chart. This lays out the whole hierarchy. Way up at the top, you've got the heavy hitters, the most reactive metals like potassium. And all the way down to the bottom are the chill ones, the least reactive, like gold. Now, reactivity really just means how eager an atom is to lose its electrons and become a positive ion. The higher up you are, the more you want to do that. So the rule is dead simple. Any metal can displace another metal that is below it on this list.
Now I know what you're thinking. How in the world am I supposed to remember that whole list? Don't worry, I gotcha. Here is a super popular trick to help you remember. Please stop calling me a cute zebra. It's a little bit silly, I know, but trust me, it's a super effective way to lock this series into your memory for any test. All right, you've got the rule book and you've got the power rankings. Now it's time to put those new skills to the test. Let's see if you can be the chemical detective.
Predicting this heist is actually a really simple three-step process. First up, you just have to identify the two metals involved, the one that's by itself and the one that's in the compound. Second, find both of them on our reactivity series. And third, the metal that's higher up on that list wins. It's that easy. Okay, let's walk through one together. Will a reaction happen between zinc metal and a copper sulfate solution? Okay, step 1. Our metals are zinc and copper. Step 2. Let's find them on the series. Zinc is up here and copper is way down here. So step 3, who wins? Zinc is higher, so yes, a reaction is absolutely going to happen. Zinc is going to kick copper right out of that solution. See? Simple. You've seen the rules, you've learned the power rankings, and you've seen an example in action. So now, it's your turn to solve the final case. You ready for this?
Here it is, your final challenge. What happens if you add a little piece of copper to a solution of silver nitrate? Take a look at your reactivity series. Find copper. Find silver. Will copper displace silver? Your answer is just yes or no. Think it through.
Got your answer? Awesome. Drop it in the comments below. Let's see who our master chemical detectives are.